This is a video demonstrating the EMProbe, an automated single-probe robotic arm solution from Y.I.C technologies. This solution includes the robotic arm, a set of near-field probes, and a 90-centimeter reference mat. This solution requires the EMViewer software and a spectrum analyzer. In this demo, we are using the FSH20 from Rode and Schwarz. The DUT we are going to scan is an RFID board. In the EMViewer software, we will create a new project. We can define our default scan parameters on the project's root node. Let's select the EMProbe. The selection grid on screen reflects the reference mat included with the solution. Now, we will add an overlay image of our device. The overlay can be a PNG or JPEG file. You can also import Gerber files. Once the overlay is selected, click on the image and drag it into position as placed on the mat. The row and column numbers will help you position the DUT correctly. The overlay and DUT should be in the same position for accuracy and repeatability. The control level represents the resolution of the scan. For this scan, we will use level 1, which performs a single measurement per 7.5 mm cell. Now, we will select the mode of operation. In this case, we will use the combined node, which provides us with the frequency response across the area, as well as a visualization of power measured from each cell. The EMProbe must be aligned before use to ensure the arm moves accurately. Click the homing button and then follow the instructions on the screen. It is recommended to perform the homing without any probes attached. During homing, the LED will flash blue. Wait for the beep sound to indicate that homing is complete, and the LED will then turn green. Now we are ready to attach the probe to the robotic arm. Connect the probe to the spectrum analyzer using an RF cable. You will see a locking screw which you need to tighten to ensure your probe adapter is secured. Let's select the area we would like to scan. Unlike the EM scanner, the robotic arm can scan at different heights, which can be selected across the scanning area. This can allow you to follow the DUT topology accurately, especially if you have protruding components. The height we are selecting at is determined by the height control on the top right of the window. Moving the arm using the unlock button or the software arrows will update the control with the arm's current height. Using the unlock button, place the robotic arm on the corner of the area you would like to scan. Leave at least 1 centimeter of space to avoid potential collisions. You will see the arm's position update on the software, marked with a colored X. You can now drag the mouse across the area to select those cells. You can repeat this process as many times as needed. Click on the Analyzer tab, select your analyzer, and input the frequency range. We will be using 10 to 300 MHz. Before we start a scan, please note the emergency stop button on the bottom right. This will be activated once the scanning starts. If a collision is about to occur, clicking the button will immediately freeze the arm in place, ending the scan. Click OK and click the Start button. Give the analyzer time to configure, and then your scan will begin. The speed of the scan is dependent on the speed of your spectrum analyzer. Here we will demonstrate use of the emergency stop. If needed, reopen the node parameters and modify your area. Once completed, you can now start analyzing the data. Click to show the 3D view. Selecting a frequency of interest from the spectral view will show the location this frequency was detected. Here we can clearly see it is coming from the DC to DC converter. To zoom into the area of interest, go into 2D view and use your mouse to select the area you want to zoom into. Additionally, you can adjust the overlay visuals by moving the opacity and overlay height slider. We are now changing the device's power source to USB. Because of this, we will have to go back into the grid selection and readjust some of the scan heights. Let's perform a scan with our new configuration. Once the scan has completed, we can compare with our previous scan results to see that the noise from the DC to DC converter is no longer appearing. Now, we will perform a scan with the interleaved mode, which eliminates the probe's blind spot by performing a second scan with the probe rotated 90 degrees. We will also use control level 2, which will perform more measurements per cell to scan at a resolution of 3.75 millimeters. Once the first half of the scan is complete, follow the instruction on screen and rotate the probe 90 degrees. Push the probe up gently and move into position. You will hear the click when the probe is in place. Click OK, and the second half of the scan will start. A level 2 scan is much clearer than a level 1 scan in most scenarios. Finally, you can use the report generator to export your data into a Word document. This feature requires Microsoft Word to be installed on your system. This is the format of the template created by the report generator. You can amend the document as needed. Data sheets, user manuals, and setup guides are available at yictechnologies.com. If you have any questions, please get in touch via the email on screen or the Contact Us form on our website. Thank you for watching, and we hope you enjoyed this demonstration.